So now I'm happy to hand things over to Steve Boisvert, Knowledge Aware Consultant at Auros Knowledge Systems. Hi, Steve.
Hi, Amy. It's good to see you again.
You too.
It's great to be here with everyone today. I'm glad you've decided to come find out more about connected and model-based knowledge. The focus of today's demonstration is really to understand how connectors and model-based knowledge can be utilized to advance your ability to become more knowledge aware. A few of the things I want you to take away from today's discussion is really to understand what is knowledge as a service and how Auros as a knowledge processing or knowledge operating system provides that capability. We're going to look at how Auros IQ provisions knowledge into other applications, and specifically today we're going to look at our newest CAD connector. Our NX connector has been completely redone. I'm going to showcase that a little bit today and quite a bit more tomorrow. We're going to look at and see how to automate rule processing within another application. In this case, it's a CAD environment. And we're going to see how the data stays synchronized between the two applications. So as we get into this, one of the things I'm going to do is I'm going to start out with a little bit of a presentation to kind of ground everyone, especially those that are coming over from the beginner session. If you were part of the advanced session, Jeff did a fantastic job kind of laying out the foundation to make the model-based knowledge and connection to other applications work. But for those of you who didn't, I'm going to cover some of the basics with you guys. Let's kind of get into this. So one of the first things is, why are we focusing so much on models? And it's quite simple. We're very passionate about it. And we realize that digital models are, extensively used throughout, a variety of engineering processes. And because of that, we need an application that can communicate and ready knowledge to integrate into those models within those engineering environments to become a very valuable tool for everyone. Having a tool set that not only evaluates the models and make sure they're compliant and provisions knowledge into those models, it's very important. But also, we want to learn from how the knowledge was applied into those models. We want to gain insights. And so we're developing a tremendous amount of functionality around how can we learn from past knowledge use across projects and then generate learning cycles to improve knowledge for the next project. So that's why we're focusing so much on models. It's extremely important to us. So let's kind of get back into the whole connectors and model-based knowledge. How do we get there? And Jeff did a good job explaining this, but I'm sure you've heard us talk about how the knowledge-aware process is similar to navigation. And that, in navigation, we use GPS to detect context. And then based on that context, the navigation app provisions the right directions to the user at the right time. And it's very efficient. It's a fantastic tool to deliver knowledge at the point of use. And for us, for what we're talking about now with connectors and model-based knowledge, we're trying to do the same thing. Except instead of navigation and GPS, we want to use the tools that you use to create your projects or products and detect context from them. And once we have context, we can provision the right knowledge into those applications to help you make the right decisions and get the right outcomes, and also produce insights for the next projects. So how do we make that happen? So Jeff talked a lot about this, the fundamental technologies that we need to talk about. And for you beginners that just hopped over, I'm sure Josh talked about some of these as well. But the key things are the knowledge packet, the assessment control, and the knowledge processing engine. These three things are going to enable us to really interact with other applications and drive information and knowledge into your modeling processes. And the way we do that, we're going to start by understanding what they are. So just a quick example of a knowledge packet. A knowledge packet is a structured encapsulation of know-how. Jeff talked a lot about this. And for our application today, understanding how we're going to drive knowledge into a model-based environment, the critical piece here is one of the things he talked about in the advanced session 1, the value table, right? The embedded knowledge model within a knowledge packet. And this particular example, it's a very simple one. It's talking about minimum locator pin engagement and maximum locator pin engagement. We have some parameters in here, and they result in a parameter. The loc pin engage is a resulting parameter. It's something that we can provision into another environment, make a connection to an object in the environment, and get some insights and some outputs from. So this is a critical thing to understand here, and I'm going to go over this again once we get into the demonstration. So the structured encapsulation of knowledge, being the knowledge packet, is the first part of the equation. The second part of the equation is how do we process that? And for that, we have an assessment control. The assessment control is really the toolkit that understands which knowledge packets need to be collected, and it becomes the record keeper, understanding which projects they were applied to, how they were applied, whether, how the evaluations occurred on that particular project. And so the assessment control is that primary piece that we have to have traceability of understanding how parameters, how knowledge were applied to different projects. And the last thing we're going to look at, and we're also going to look at some sample assessments in our demo, is the knowledge processing engine. And this is critical. So on the right-hand side, we have Auros IQ, and it's our knowledge repository. So we have some knowledge packets there. The left-hand side, we have the applications where you conduct your work, whether it's a CAD environment, a CAE simulation tool set. It could be a PLM system. It could be a 3D model viewer. It could be a whole host of different applications. It could even be an ERP system for that matter. The thing that we want to do is detect context. And based on that context information, we want to harvest the relevant information in the form of knowledge packets that apply to that context. Based on that harvested information, we want to collect those key parameters from within those value tables. In the case of a CAD application, we want those key parameters that exist in those logical models inside of the knowledge packet, and we're going to provision those back into the CAD application in this particular example. Once we have those parameters into that CAD application, what we're going to do is attach those parameters to either other parameters that exist within the model, so make a connection to existing parameters that are in the model. Maybe we could attach them to other attribute information of the model. Maybe we want to attach them to a feature or dimension or even a measurement within the model. So the key thing here is we're going to attach those parameters to something in the model. Once we make that attachment, we're going to collect the values, send those back into the knowledge processing engine, where the knowledge processing engine is going to produce an output state and a response that we're going to send back into, in this case, the CAD environment, where we're going to have visual indicators of how well that knowledge is being evaluated inside of that environment. So it's extremely important and a very useful tool to have those visual indicators in that modeling environment, especially for a designer, to have instant feedback as to what's going on with that model, making sure they're compliant to all the latest requirements, design standards, best practice, whatever that happens to be. But also, those same responses are stored back within the knowledge repository in the form of reports. So if you're not, a CAD savvy person, you don't necessarily have to go into the CAD environment to see the health of a particular model or assembly, whatever it happens to be, because there's some data synchronization that happens across the two applications, and you'll be able to see, gather reports and insights in either application. So one of the questions I often get is, that's great. Do you have this connector or that connector? Have you done this or have you done that? And so I like to include this slide because it kind of grounds people as to what are the out-of-the-box CAD connectors that Auros Knowledge System supports that we've developed and that we deploy at customer locations. And we have, basically the big ones: NX, CATIA V5. We don't have V6 yet. We're talking about developing that one. Creo, SolidWorks, Autodesk connectors. For those of you that might be in shipbuilding, we do connect to Ship Constructor. And we even have a general purpose CAD connector tool. That really doesn't even matter the CAD application. Still uses the same principles that I just outlined from the knowledge processing engine. So for today, what I want to show you is our newest CAD connector. So we've spent a tremendous amount of energy overhauling our NX connector. The new NX connector does the same thing that the old one does, just better in a more refined user experience. But we're still going to have broad-based digital knowledge provisioning. So we're going to provision knowledge into the modeling environment. We can still drive models and assemblies. We can check parts at the part or assembly level. You're still going to be able to see how we connect the model and aspects of the model to the single source of truth, being the knowledge that's contained in the knowledge packet. You're going to see how we have out-of-the-box persistence in reporting of conformance between the connector and whether it be the knowledge processing engine or an assessment control. And from that, you're going to see how we can gain parameter analytics. So as values within the model change, those parameter values actually get stored back into the application, and we can develop insights and new learning from how those how that knowledge has been applied to a particular model. So one of the things we're going to talk about today really quick, and you're going to see tomorrow, is we have 4 use cases that we've identified when we start talking about CAD connectors. So the 4 primary use cases that we tend to talk about, one being we're going to start completely from scratch. Blank sketch, nothing in there. We're going to bring the parameters in, use the knowledge from within the parameters to help drive the sketches and develop a model. That's one use case. I'm not doing that one today, but that's one that we can do, and that's one that you'll see us start to demonstrate more and more in the future going forward. It's an extremely important one. I think maybe in tomorrow's demonstration, in our joint presentation with General Motors, you might see a portion of this. Use case 2 is whenever we have an existing model. It could be an assembly, it could be a particular part. That part may have parameters, it may not. And that's a pretty common use case where we want to take an assembly or a part, and we want to check it based on the knowledge that we have. And that's going to be the use case I'm going to demonstrate today. Use case 3, when we have a smart part or template model, fully parametric. We can drive the model. We can make it react to changes from Auros, and then we can make Auros react to changes in the model. Very common use case. We've done that one in the past at the IKAA conference. And then use case 4 is whenever we want to integrate knowledge-based engineering or custom applications with knowledge from within the connector. So blending the 2 concepts together, extremely powerful. I've touched on that one in the past before as well, but it's not going to be the focus today. Today we're going to look at the NX connector and the new version of our Auros NX connector. So with that, I'm going to hop out of the PowerPoint, and let's actually start doing some real stuff. So I'm going to kill this. We're going to open NX. You see here, I have a model open. It's an assembly. It's a cup. Actually, if you were part of our IKAA conference, I don't know, maybe it was like 4 or 5 years ago, we did a whole demo series on the Cool Cup company, and we started to develop a few more demonstrations around this idea of Cool Cup and the processes that a cup company may utilize, and they're all based on. I have my Turvis cup here, and it's kind of the inspiration came from this, where the idea is kind of simple, but yet it's still complex enough where we can demonstrate some functionality and concepts in a meaningful way. So for today, we're using the Cool Cup, and it's an assembly, like I mentioned, but we're only going to really work on the outer cup for today. So I'm going to turn the inner cup off. Now, kind of going back to those fundamentals, we need to start from knowledge. So I'm going to open up Auros, and we are going to look at the knowledge that we're going to apply into our cool cup. So for that, I'm going into my product engineering community of practice, where I have all of my knowledge packets around my cool cup. And one of the things I want you to look at is I've developed a knowledge set, the knowledge packet set. So for our demo, I've already kind of defined the context. I'm kind of shortcutting things in the interest of time, where I'm saying I only want to verify these 3 knowledge packets, right? I have an ergonomic standard, a product design standard, and another product design standard. One's for the grip width, one's talking about this depression height, and another one's talking about wall thickness. All of these have value tables. Each of these knowledge packets have a value table. You can see this one talks about a max cup radius, and the resulting parameter of the max cup radius is this outer center line diameter OD. So each of these value tables have a parameter, and those are the things we're going to share into NX, into our outer cup model. So let's hop over. So here's the knowledge we're going to use. Pretty simple demonstration. So let's hop into NX. Now, before we get started into the model, I want to show you a couple things about the model. So I'm going to hit this part navigator, and in the part navigator, you can see my, my sketch history, my part history here. And one of the first things I want to show you is this is use case 2. It's not a completely dumb part. I do have some parameters already embedded into the model. And you can see that here in the sketch. I have the outer center line diameter defined for that feature, and I have this depression height already defined, which is important when I show you how, when we connect the knowledge to the model, things are going to start happening, and it's because I have some of these parameters already defined. So let's kind of get into it. So from within the environment, I'm going to click on my Auros tab, and I'm going to open up my Auros connector. So now it's opening the new version of the NX connector, and you can see some things starting to happen. So the first thing that's happening, that kind of happened in the background, was it actually knows who I am, right? It knows who the user is, and it knows what instance, Auros IQ instance, I'm trying to get my knowledge from. The second thing that happened is it found the active part. Remember, it was an assembly, but I made the outer cup the active part, and it knows that I want to, provision knowledge into this outer cup. The third step I got to do is I got to tell it, in this particular example, what knowledge do I want to connect to? And we looked at that, and we looked at that set. It's 1367, and I'm going to connect to those knowledge packets. And you can see what happens when I've connected to our knowledge source. We get a response from the connector that says, all right, I found the knowledge packets. There's 3 of them. I have 1 ergonomic standard and 2 product design standards that I'm going to provision into this outer cup model. And it results in 3 parameter evaluations. Okay, that's good to know. And I'm going to hit apply. And now what's happening is the connector is communicating with Auros IQ and the knowledge processing engine, and it's provisioning in those parameters that were part of that, were part of those knowledge packets. And you can kind of see what happened from there. Those 2 parameters that I already had in the model matched parameters that I already had in those knowledge packets. So instantly they began to evaluate themselves. And you can see that here with 1 red and 1 green. And you can kind of see in our revised NX connector that you can see basically the set that we're connected to. We can see the evaluations. You can see we have a pass, a fail, and an incomplete. And we have some warnings on here, and it's actually telling me one of the parameters that were in that set isn't found in the model. And I can kind of also see that in the part navigator now, where I also have a representation of my pass, fail, and my broken link to knowledge that the application is trying to provision into this connector. So one thing we do is we can start to deal with these things. So if I click on the red items, it shows me which item is red. It's my outer depression height distance is red. And if I expand that, I can see some details. I can get directly to the knowledge packet in case I have some questions about how this is supposed to be applied, what the intent of this particular knowledge is. I have access directly to the knowledge from within the CAD application now. Let's hop back over to our connector. I'm getting all sorts of insights from here. I'm seeing in the model that the depression height is 4 millimeters, but the rule is telling me I should at least be 10. And I'm getting an end user message provided from the knowledge processing engine that here's why I'm failing. This value should actually be 10, but it's only 4, hence I'm failing. So let's kind of deal with the red first, and then we'll work with these other things. So the thing we're working on here is this depression height. And what I want to do is we're gonna change it. Let's say we're in the, early enough in our design phase. Maybe I'm in the concept phase. I found out that hey, this should be 10. I had set to 4. Maybe I didn't know any better, but now I do. And I want to just change it right in the model. So I'm going to change the value for outer depression height, and I'm going to drive that from the connector into the model. So you're going to see two things happen. One thing is that new values go into the knowledge processing engine, getting reevaluated. And now we no longer have a red state within our ring chart here. And 2, that value got pushed into the model. And now our model has been updated with the correct depression height. So now our part navigator, you can see here, we have visual representation of the two things are now green, which is really important. And we can see things are passing as they should. But I still have this one thing I need to deal with. I have this warning that there's a parameter not found. So let's take a look at that. Let's look at the parameter that's not found. So it's telling me that the outer wall thickness distance is a parameter that's coming in from the knowledge source that isn't part of my model. So what I want to do is I want to make this part of the model. So I'm going to hit apply. And what's going to happen is it's no longer going to say parameter not found, right? So now it's taking that parameter and putting it into the model. Now it's telling me the parameter is not connected, meaning it's not doing work. It's part of the model, but it's not attached to a feature, an attribute of the model, a dimension, a sketch, or a measurement in any way. So it's not really doing work. It's not connected to anything. So let's address that. So let's take a look at this. We have our cup, and we have our connector here, and it's telling me this is not connected. The outer wall thickness isn't connected. So what I want to do is, for this particular example, I just want to take it and I'm going to say, all right, for this one, I want to use a measure. And I'm going to take this particular parameter and I'm going to attach it to the thickness of the cup by selecting this edge and this edge. Well, let's zoom in a little bit so I can grab the right edge. And it gives me a distance of 2.033. I hit OK. And now that parameter, outer wall thick distance, is going to be attached to a measure. And that measure stays persistent. So as that wall thickness changes, maybe the shell feature changes, now that value will stay persistent and will react. So now I no longer have a parameter that's not found, and I no longer have a parameter that's not connected. Everything's connected and is creating evaluations, and I can see that. Everything is green. So one final thing as part of this demonstration, I want to write this back into Auros. I want to save this. I want traceability that I applied these. So what I'm going to do is I'm going to create an assessment control. I'm going to choose my community of practice, right? And that was product engineering. I should have picked something more towards the top. But I have my list of product engineering. Where is it?
And then Steve, when you get a chance, John is wondering, just making sure you didn't already answer this, but does the product need to design with the parameters that are set up in the Kpac?
Does the product need it to design with the parameters that are set? No, I mean, you could define those in the model and then attach the parameters that are in the model to the parameters in the Kpac that are defined in the Kpac. So it doesn't have to start with the the parameters that are in the Kpac.
Thanks.
So now I'm
And
just going to
we have like 1 more minute. So
Yep.
yeah.
Last thing. I'm creating the assessment control. You're going to see now we're tied to an assessment. So I'm going to open that assessment. We're going to have all of the values that were published in CAD pushed back into the assessment control. I have traceability. And then one last thing, because I talked about data synchronization. What happens if I change a value? So now let's say I make that 8. All right, let's go back into our model. I'm going to say, all right, this one is now 8. I'm going to submit that change, right? This might change to red. But I want to show you how the connector reacts. And it'll tell me, I am no longer synchronized. The values that I've changed in CAD do no longer represent the value that I have in the assessment control. And so the applications are smart enough to know, when they are out of sync. So with that, that's where I want to leave it for today. We have another demonstration with using the same connector tomorrow. It's going to be a little bit more extensive than what I went through today. But hopefully you can see how we can provision knowledge into a modeling environment, and we can see how the application of that knowledge is provided in there, and how it reacts whenever basically there's any type of model change or assessment change.